Hello there, I'm your host Dan Rojas, and this is a quick little test with the AXIAL FLUX. These are the saw blades. I've glued the magnets in place. I'll show you all that in a future video. I just want to give you a quick update. I mentioned about using PVC. I have them centered with 1/2-inch PVC and the slips to keep everything apart. And CPVC with a little sanding actually fits in 1/2-inch perfect. The reason that I like 1/2-inch CPVC is it fits in these wheels perfect. So everything goes along pretty good. You can get a pretty easy bearing setup. You can do this more intricately if you want. This is just hooked to a drill. What I have is, before I wind my own coils, I want you to see this. This is from a hard drive. This sits inside across the huge neodymium magnet that hard drives have, and these is from an older hard drive. That's why there were so many platters. These sit on the platters. But they have a nice coil there that's machine wound. It's very thin wiring. Give you a higher voltage but very low amperage. So this isn't a high amperage test. I'm just going to hold it and show you with this meter, with this single coil. Keep in mind you'd have 9 in there. So that'll boost your amperage and you can adjust your voltage. But this is just with a single one, and it's not optimal for this. You want your coils to be, the inner diameter needs to be the size of your magnet, the outer diameter just a little bit bigger than the magnet. So this would be ideal if it was the exact size. This doesn't fit all the way down in there, so it's not a perfect test, but it gets pretty good voltage. But I made a mistake. I had the coil wire taped down so they wouldn't rip off like this, and I don't know if you can see that or not, but there it is right there. So one is still there, the other one goes somewhere on here. So if you do this with your coils, you're pretty much screwed. So you want to, I had these taped down, but the tape pulled off. But you can see hard drives, actually, if you take this, you have a linear generator there. If you go back and, if you move this back and forth really fast, you have a weak alternator, because there's very powerful magnets with opposing poles going that this goes through. So that is how these older hard drives work. This is riveted together, so I have, actually no it's not, torque bit. I can do it. So I just pulled that apart, and there are some very strong magnets there. Let's see. So keep those off to the side for later use. These are the ones, to get this apart, these are riveted together. So your magnet set is. But that coil, actually, you can take it off and make a cool little generator. So this is what I'm after right here. And that I couldn't salvage that one coil is that this is actually goes right into the resin base that they have there. So it's snapped off there. If you snap it off there, you're done. So I'm just holding this in there. I'm going to reverse the drill. So that is 8 volts about. It actually got 9 with the other one. Alternating current. You'd have to run that through a rectifier to get it to DC power. And that is just one single coil that is not the optimal size. Now, one thing with the coils, the finer the wire, the more wrapping you can do, the more turns. This is machine wrap, so if you can do this by hand, you're going to be a genius. But if yours aren't going to look this pretty. But the more compact you make these, the more wiring you can fit in there, and the higher the voltage. The thicker the wiring, the higher the amperage. So there's like a fine line to get the optimal wire, so your voltage is enough to charge and your amperage is enough to be worth a darn. So anyways, this was just a quick test using a hard drive Coil. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos. The nice thing about this is that everything just pulls apart. Without that back on there, it does that. They stick together. So you wouldn't want to do this with super strong magnets because they will pinch the crap out of you. Even these will give you a nice... So, like right now, it's got my thumb. Ouch. So, this is the coil. This is the pole configuration, and all that this is PVC slip thread, or PVC 1/2 inch with the coupling for it cut so that the blocker's off of there, and then the back. And then when you put these on, you just want to make sure that you don't stick them together. And one will turn the other, so they don't have to be shafted together. The force of these together is so much that they pull each other around. You should shaft them together, but you don't have to. These weren't, and you saw how they worked. This is a really ugly glue job, but it's just actually waterproof wood glue. So they'll have a tendency to do that. Once this is pushed into place and they're flushed up, they can't do it anymore because the back is actually pressing against the PVC. So if this is nice and tight for permanent, you'd want to, I don't know if you'd want to glue them. I just put like a little pin through there.